In this particular slide, you may occasionally get the feeling that the tissue is looking at us rather than us looking at the tissue because, as you can see, this is an eye. Here is the lens of the eye, which is a little bit fragmented due to having to try to cut this very crystalline-like substance, but it is still one of the best slices of eye I've ever seen in my life. Here is the pupil, which is the space between the two tips of the iris. Here is the iris. Here is the cornea. Here is the sclera. Here is the ciliary body. Here are ciliary processes. And now that we've said that in terms of point and see, let's look at the eye in terms of its overall organization. There's always three classical layers of the eye described. They're called tunics. The outermost tunic is called the fibrous tunics because it's mostly fibrous tissue, and that consists of the cornea, which is the transparent part of the fibrous tunic, and then there's the sclera, or the white of the eye, which is also fibrous tissue, but it's not transparent. Where the angle of the cornea meets the greater radius of the sclera, this is called the limbus. The middle tunic of the eye is called the vascular tunic. It's also very, very pigmented. It consists of the iris over here. It consists of the ciliary body and ciliary processes, and further back into the eye, it consists of this entire pigmented area here called the choroid, C-H-O-R-O-I-D. The layer of the eye which is not apparent in this specimen, but is almost about to be, is the neural tunic. And that's the tunic that is reserved for the retina. And the retina are your actual cells where light perception takes place, where you have photons of light ultimately converted into nerve impulses. Unfortunately, you don't see much of that, but it's the only tunic that is in the posterior part of the eye, whereas the other two tunics, the fibrous tunic and the vascular tunic, are in all parts of the eye. So let's concentrate on what we could see, and a good place to start is the cornea itself. The cornea is nothing but fibrous tissue and a couple of epithelial membranes. There's the anterior epithelium, also called Bowman's epithelium. And there's the posterior epithelium, you could see along here, also called Descemet's epithelium. And the little membrane right underneath the epithelium would then be called Bowman's and Descemet's membrane, respectively. Here's the anterior epithelium, also called Bowman. Here's Bowman's membrane right underneath it. Here is Descemet's epithelium, and technically Descemet's membrane. Otherwise, the rest of the cornea is nothing but fibrous tissue, fibroblasts, and the collagen fibers are arranged in a very unique way, and you would probably guess that that unique way is such that it could be transparent. And the greatest amount of refraction of the eye takes place in the cornea, and here we are. And the reason why I'm so smart on eye is because my son is an ophthalmologist. So, you know, there's nothing you could say about eye that I don't already know. And I even know more than he does, but he doesn't really admit to that yet. Here we are traveling down the cornea now towards the limbus. And you can now see that the Bowman's epithelium is starting to get a little bit darker and more pigmented, and is now turning into the conjunctiva of the cornea, also called the bulbar conjunctiva, because we are now in the scleral portion, and here's the bulbar conjunctiva of the sclera. And the sclera is also fibrous tissue, but it is not really as transparent as a cornea. I heard that if you blow through it with a soda straw, so you get warm air on it, it'll become quite a bit more transparent. Everything that's pigmented in here is now part of the middle tunic of the eye, called the vascular tunic. And that consists of the choroid within the globe, the ciliary body and ciliary processes in this area near the limbus, and then the iris anteriorly. This is the ciliary body. These are ciliary processes. They contain these small little zonular fibers, which are like tiny tendons, that help flatten the lens, and they pull by virtue of these smooth muscle fibers in the ciliary body. Notice that there is this layer of epithelium which extends all the way from the retina, coming up through the ciliary body, all the way to the posterior portion of the iris, and this is called RPE, for retinal pigmented epithelium. And RPE is very unique because it is truly derived embryologically from brain tissue. And because you could see the RPE wraps around the inner portion of the pupil, or let's say the distal portion of the iris, which is visible to clear view. This is the only place in the body, to my knowledge, where you could actually see brain cells. These smooth muscle fibers near the distal portion of the iris are constrictors under parasympathetic control. And if you look closely, and we'll look a little more closely, you can see they're smooth muscle. And yes, they are. And then you'll occasionally see more proximally or in the iris other little bundles of smooth muscle, and that would be the dilator, and they're under sympathetic control. You know, the sympathetic system dilates your eye and the parasympathetic system constricts your eye. And they would be further out, and they're not quite as easily seen as the constrictor muscles, but I guarantee you when you look through these iris and you see approximately here or here little strips of smooth muscle, you know that that has to be involved, geometrically speaking, with constricting of the eye, or pulling the iris to make that pupil wider, whereas this little group of muscles near the very end of the iris are involved in constriction. Notice even the lens underneath has a little epithelium covering it as well. What else do we want to say about the eye? What else can we say about the eye? I don't think we can. It's too bad we can't see the retina, but really, you know, you could always look at the retina and talk about the various types of cells in it, in the classical layers, you know, the granular layer, the inner granular, the outer granular, blah, blah, blah. I don't believe in that kind of stuff. I think when you see a retina, you know the 5 or 6 different kinds of cells in classical layers you could get there. Also notice that we have a lot of blood vessels here. And also notice that here's that RPE coming all the way down eventually towards the retina, but also notice we don't have a retina. We have a choroid, we have a sclera, we have connective tissue surrounding the sclera, we have bulbar conjunctiva, and really backing into again our shotgun philosophy, I don't think there's any possible thing on this slide that you can't identify, because we have identified everything, and therefore you know what we're going to say here. Thank you very much.